Hello, everyone. Welcome. Thank you for joining us today. I'm here with Scott McKay from Fournier Industries, here to discuss engineered solutions at the interface of digestion and digestate dewatering.
Well, thank you, Ryan. Hello, everyone. As you probably know, in Quebec and all across Canada, biogas and RNG projects are moving from the demonstration scale to critical infrastructure. As projects mature, the discussion shifts from concept viability to measurable performance. So should it be, organic loading rates, volatile solids reduction, cake solids of the dewatered digestate, energy balance, life cycle costs. And I'd like to point out that since 1960, Fournier Industries has been designing and manufacturing heavy industrial equipment for very demanding industrial environments. And that manufacturing foundation is what supports our work in biogas process infrastructure. So our focus is not a single component. It's really system performance mainly across anaerobic digestion and dewatering interface. As you know, projects in Canada must address variable source-separated organics composition, in some case co-digestion with municipal sludge, as for example, the city of Quebec. Seasonal temperatures impact on biological stability and on the overall equipment and systems that are, even if it seems obvious, they are too often overlooked. There's footprint constraints in existing facilities, so the available space may be constrained, so it's difficult to install large anaerobic digesters. And also there's increasing regulations on minimum dryness and disposal requirement for the digestate. So in this context, digestion efficiency and dewatering stability are variables that are become, increasingly important and can have the impact, very important impact on projects' viability. So at Fournier, Fournier has two main products in addition to having all the experience with dealing with organic waste. One important technology is the HPD, high performance digester, which is designed to operate at high organic loading rates while maintaining process stability. So problem with high load anaerobic digesters is oftentimes their instability. They, for example, you can have a washout of your biomass, which doesn't happen with the HPD because it was designed for a higher organic loading rate. So there's an improved hydraulic behavior that limits short circuiting, that enhances VS, volatile solids destruction, and increase biogas productivity for each volume of digester. And most of all, very compact footprint. So the objective is straightforward: maximize upstream mass conversion. On the solids management side, so once that these organics have generated their biogas in the digester and come out of the digester, the product that Fournier offers is the Fournier rotary press, which is engineered for stable, continuous dewatering under variable feed conditions. So the way the rotary press operates, it's very fundamental. Is the impact is that it adjusts automatically without any operator intervention to changes, variations in the digestate composition and dewaterability. So this provides consistent cake solids, low polymer conditioning, and mechanical simplicity and very easy equipment to maintain. So this is also a very important piece of equipment because in many cases we're very, people can be very focused on the biogas generation, but the digestate, so the byproducts that are coming out of the digester, the other byproducts than the biogas, can have a very important impact on, again, the profitability of the installation and the overall operating cost and revenue generation. So in Canadian projects, the economic model increasingly depends on biogas yield optimization, energy recovery integration, reduced residual mass, and long-term OPEX control. So as an integrated digestion and dewatering strategy allows engineer to model the entire solids pathway rather than oversizing downstream infrastructure to compensate for biological variability. So in these conditions, Fournier's contribution is grounded in heavy industrial fabrication excellence dating back to 1960. Which was a good year, I believe, because that's also the year I was born. So, little personal note here. So that background of Fournier translate into mechanical durability, very high control on fabrication quality, and equipment generally designed for long service in municipal and industrial environments. So in biogas infrastructure, reliability is not a secondary consideration. It affects availability, revenue stability, overall life cycle cost. So as I'd like to conclude on this, as Canadian biogas and RNG facilities scale up, the discussion increasingly centers on performance predictability and system optimization. So our role at Fournier Industries is to provide engineered solutions at the digestion and dewatering interface that directly and strongly support these objectives. So thank you so much for your attention and your time. Thanks, Ryan, for hosting this.
Great. Thanks, Scott, for your time as well.